next example is talking about using a binary predictor to perform a linear regression. So basically, here we are going to be creating a new variable from the hours worked variable. So we're going to transform that variable and recode it into two different variables. And then the variable is going to be split into those that have worked 70 hours or more, and those who have worked less than 70 hours. So let's go back into SPSS and see how that is done. So we go to transform, recode into different variables, and then we click on hours worked, and that's it. So what is the new variable name? I believe they said hours GT70. So GT70 and label. So the label just explains what the variable stands for. Okay, so we now come into the so we come here and click on old and new values, and then you click on range through highest. So from 70 and above, you just enter 70 here, and then from 70 and above, we give it a value of 1, which means a value of 1 for this variable means that the person has worked 70 hours a week or more, and we just add that 70 to highest. Then all other values, we give it a value of 0, and we add that as well. So if the person has worked more than 70 hours or more, it's going to code it as 1, and otherwise it's going to code it as 0. Let me just check to see that I've not I have not inverted it. Yes, so this is it. And then we just click on continue.
Wait, sorry, please, how do you add the else for 0?
Okay, so let me remove everything. When you come here, range through highest, that's 70 through the up until the highest number that you get, the value is 1, and then you add, and then all other values, you say 0, and then you add that, and then click on continue. And then once you have done that, you click on this change, and then you say OK. And then once you come back into the variable view, you can now see that new variable has been created. The name is hours GT70. And if you come into the data view, you also see it here, and you see that some of them have a value of 1, and some of them have a value of 0. You see that this is greater than 70, and it has a value of 1. This is 70, it also has a value of 1, because we want those who have worked 70 hours or more in a category, and those who have worked less than 70 hours in a separate category. And you can see that this has been reflected in our data set. So that's That's the process of recoding into a new variable. So we're going to go ahead and do a linear regression using this new variable that we have coded, that we have recoded, and it's basically the same process. And the question here now that we're trying to answer is if working for more than 70 hours in a week is related to the mental health score. So we have already determined that the number of hours a week has some impact on the mental health score. But then what about working overtime, basically, much more than overtime? Anyway, working more than 70 hours a week, whether it's related to the mental health score. So we can go back into SPSS, yes, analyze regression, linear regression. So instead of hours worked as our independent variable, we're going to use the new hours GT70 that we just created. And then we can go ahead and click on OK. So this gives us our output. So the model summary. We have the ANOVA table. So let's look at and see whether or not this model is significant. Right off the bat, we can see that this is 0.2, which is greater than the alpha value of 0.05. So it's not statistically significant. But then we can also come here. Yeah, we can also come here and see. So this is the dependent variable. This is the independent variable, and we can see, does this basically when you are looking at this, we are basically asking, does this working more than 70 hours a week, does it have a significant impact on mental health score? And you can see this says, the model says no. So we've been able to answer that question. Let's go back to our slide and see what the output is. Where is it? Right, I've skipped a few. Okay, here it is. So you can see this is the hours GT70 variable. This is the ANOVA table with the significance of the regression model. And we can also see it. Where is it? We can also see it here on the coefficients table. So it's not a statistically significant model. So it's a poor, basically you interpret it, and the way you report it, you say that this working more than 70 hours a week is a poor predictor of mental health score for in this population. So that's the interpretation. If just so that we remember, we're aware, regression is all about making predictions from data that you are observing. So once you have a regression equation, and then your linear regression equation, like the one we had for the previous example, you can take a random member from that particular population from which these participants were sampled and enter their values into the equation. And then you should be able to get a rough idea of what their mental health score would be. But then the better your R score, then your R square, then the better your regression model. If you remember from the lectures, the R square also tends to improve when you add several variables, but then there's something also called the adjusted R square. So we're going to use a categorical variable to test for linear trend. So basically, for this one, we're still going to record the hours worked variable, but then we're going to record it in stages into different categories. So if you can see the first category, it says range value through lowest. So from 0 to 40 hours a week. This one is 40.001 up to, sorry, it's just my laptop shocking me for some reason. From 40.001 up to 60 hours a week, then this, and so on and so forth, up to 80 plus hours a week. So once you have, once you categorize your data like this, you'll be able to use it in your predictor, in your regression model, and you'll be able to see, number one, whether this hours worked is related to the mental health score, and also you'll be able to see at what point the relationship becomes stronger or weaker. So let's go and see. So let's go ahead and go and code this, recode this variable into a categorical variable. Let me just put this side by side just so that I can see what I'm supposed to do. So you can do this on your laptop. So transform, recode into different variables. So it's still this, so we're still going to use hours worked, and we're going to be recording it into, a variable called hours cats. And coming here, we say range through lowest through 40. Sorry, let's delete this, remove this. So range lowest through 40 is coded as 1. 40.001 is, yeah, sorry. So you now come to range again, right? For the second and third categories, you come to range. So from 40.001 to 60, you code it as 2. Then you come to 60.001 to 80, and you code that as 3. Then the last category, range through highest. So anything 80 and above, we're coding that as 4. And then we add that. Let's see, continue. So we click on this and click on change and say OK. So we come here, we have the variable called hours cat. So we have been able to record that into a categorical variable. You come to the data view again, you see hours cat, and you can see that they have been sorted into their various categories, 1, 2, 3, and 4. Go to analyze, regression, linear regression. So instead of using hours GT, we're using hours cat, and that we're going to use in creating our regression. So let's go open. So this is the variable hours cut against mental health score. Sorry. Okay. Hello, everyone. Sorry about that. I got disconnected briefly. So we were doing the regression using a categorical variable. Hello, can you all hear me?
Yes, sir, we can hear you.
Okay. Sorry, Stats Clinic. Can you enable me to share my screen? I seem to have lost the ability to. Hello, Sion. I think you are the host now. So can you enable my screen? Okay, thank you. Okay. I actually had to restart. Okay, I hope this has saved the categorization. It hasn't. So I've lost some of the work we did, but not to worry. I'll just go through it quickly. So I was walked into range through the lowest 40, then 40 times 0, to 60, 60.1 to 80. Then 80 and above. Okay, so my recording has worked, and then we're just going to go ahead and do the regression.
Sorry, please, can you just back up a little?
Okay. What are you confused about? This is just the recoding of the variable into a categorical.
Yes, where I am now is where we are, the page of the recoding, 80 through to the highest. Am I to really continue?
Yes.
Okay.
Yeah. So
and what's next? Like,
where was it? Yeah. So just click on continue.
Now.
Yeah. When you click on continue, you come here and click on change and click on OK. Okay. So regression for is a dependent variable. Ours category is the independent variable, and then we click on OK, and we have our output. So if you have observed anything from our labs, the t-tests and other tests that we have been doing, the ANOVA, the simple linear regression, and now the simple linear regression and the use of binary and categorical variables in doing the regression, you can see that it doesn't really take time. It takes seconds to bring out the output. And what might even take more of your time is trying to decide what type of test you want to do and how you want to do it and how you are going to interpret the result of the test that you have done. So does anybody want to give us an interpretation of this one, of this regression model, and what you think it means? Okay, I'll just go ahead and interpret this. So this is the this is the ANOVA table. As usual, it gives us significance, which also can find here. And we can also find the equation for the what's it called, for the regression model. So if you look closely, you find that this is statistically significant. And that basically tells you that based on, so the categorization of this variable mental health score and hours worked basically is just to test it progressively against this mental health score to see if you are more likely to have a poor mental health score depending on the category that you are. So if you are in the first category, you are likely to have a better mental health score than the second category, and the higher your number of hours worked, so the statistical significance is given from this significance. This is the p-value. This sig is the p-value for this regression model. And as we know, we usually set our alpha, that's the significance level, at 0.05. This is 0.009, which is less than 0.05. And that's the reason why we say the model is statistically significant. So based on the categories, if you enter this, if you enter the equation, let me just put where's the text, annotate text. Um, 25.829 minus 0.731. So if the person is in category 1, you enter it like this, then you are going to get something like this. So basically, where is our? So for this particular one, I did not for this particular model, I did not export it with confidence intervals. But I think to explain this better, I'm just going to export it again, so that with the confidence intervals, you'll be able to make a clearer interpretation. Oh, come on. Confidence intervals, yes. Okay. So this is the regression coefficient for this particular what's it called now? Independent variable, but then it lies between this and this. So also the constant. So when you calculate using this, you can also calculate using these, and you get an upper and lower value. And then you'll be able to say that for, let's just do this. Where's my annotation? Text, annotate. Let me just put this, make this very big. So this gives us HS 25.829 minus 0.731. So that's for the first category. And this will give you the approximate score, mental health score that somebody from this category is likely to have. So somebody that works 40 hours a week or less is likely to have this, when you work this out, is likely to have this as their mental health score. But then, since we are giving the average, we also need to give the confidence interval, and then we can do it in this way and pick the lower bounds. So the lower bound for both the constant and the coefficient. There's so let's just say lower bound LB, using this 24.157 minus 1.276 multiplied by 1, then the upper bound, $27.501 minus 0.187. So this line will give you the predicted mental health score for somebody that is in category 1, and this will give you the lower bound of the confidence interval for that predicted value, and this will give you the upper bound for the confidence interval of the for that predicted value. Does this make sense?
Yes, sir, but I have a question. If this is for someone in category 1, will the formula be different if the person was in category 2?
Yeah, you just change this with 2.
Oh, all right, sir. Thank
you. Yeah, you just replace it with the category. Okay, let me clear. Okay, yeah. Clear all trans. Okay, so that's the